Effects of climate change are well documented and growing for Earth's natural environment and human societies. Changes to the climate system include an overall warming trend, changes to precipitation patterns, and more extreme weather. As the climate changes, it impacts the natural environment with effects such as more intense forest fires, thawing permafrost, and desertification. These changes impact ecosystems and societies, and can become irreversible once tipping points are crossed. Climate activists are engaged in a range of activities around the world that seek to ameliorate these issues or prevent them from happening. 1. Some climate change effects: wildfire caused by heat and dryness, bleached coral caused by ocean acidification and heating, environmental migration caused by desertification, and coastal flooding caused by storms and sea level rise. The effects of climate change vary in timing and location. Up until now, the Arctic has warmed faster than most other regions due to climate change feedbacks. 2. Surface air temperatures over land have also increased at about twice the rate they do over the ocean, causing intense heat waves. These temperatures would stabilize if greenhouse gas emissions were brought under control. Ice sheets in oceans absorb the vast majority of excess heat in the atmosphere, delaying effects there but causing them to accelerate and then continue after surface temperatures stabilize. Sea level rise is a particular long-term concern as a result. The effects of ocean warming also include marine heat waves, ocean stratification, deoxygenation, and changes to ocean currents. 3. The ocean is also acidifying as it absorbs carbon dioxide from the atmosphere. 4. The primary causes 5 and the wide-ranging impacts 6, 7, 3 to 36 of climate change. Some effects act as positive feedbacks that amplify climate change. 8. The ecosystems most immediately threatened by climate change are in the mountains, coral reefs, and the Arctic. Excess heat is causing environmental changes in those locations that exceed the ability of animals to adapt. 9. Species are escaping heat by migrating towards the poles and to higher ground when they can. 10. Sea level rise threatens coastal wetlands with flooding. Decreases in soil moisture in certain locations can cause desertification and damage ecosystems like the Amazon rainforest. 11. 9. At 2 degrees Celsius (3.6 degrees Fahrenheit) of warming, around 10% of species on land would become critically endangered. 12. 259. Humans are vulnerable to climate change in many ways. Sources of food and fresh water can be threatened by environmental changes. Human health can be impacted by weather extremes or by ripple effects like the spread of infectious diseases. Economic impacts include changes to agriculture, fisheries, and forestry. Higher temperatures will increasingly prevent outdoor labor in tropical latitudes due to heat stress. Island nations and coastal cities may be inundated by rising sea levels. Some groups of people may be particularly at risk from climate change, such as the poor, children, and indigenous peoples. Industrialized countries, which have emitted the vast majority of CO2, have more resources to adapt to global warming than developing nations do. 13. Cumulative effects and extreme weather events can lead to displacement and migration. 14. Changes in temperature. Over the last 50 years, the Arctic has warmed the most, and temperatures on land have generally increased more than sea surface temperatures. 15. Global warming affects all parts of Earth's climate system. 16. Global surface temperatures have risen by 1.1 degrees Celsius (2.0 degrees Fahrenheit). Scientists say they will rise further in the future. 17. 18. The changes in climate are not uniform across the Earth. In particular, most land areas have warmed faster than most ocean areas. The Arctic is warming faster than most other regions. 2. Nighttime temperatures have increased faster than daytime temperatures. 19. The impact on nature and people depends on how much more the Earth warms. 20. 787. Scientists use several methods to predict the effects of human-caused climate change. 1 is to investigate past natural changes in climate. 21. To assess changes in Earth's past climate, scientists have studied tree rings, ice cores, corals, and ocean and lake sediments. 22. These show that recent temperatures have surpassed anything in the last 2,000 years. 23. By the end of the 21st century, temperatures may increase to a level last seen in the mid-Pliocene. This was around 3 million years ago. 24. 322. At that time, mean global temperatures were about 2-4 degrees Celsius (3.6-7.2 degrees Fahrenheit) warmer than pre-industrial temperatures. The global mean sea level was up to 25 meters (82 feet) higher than it is today. 25. 323. The modern observed rise in temperature and CO2 concentrations has been rapid. Even abrupt geophysical events in Earth's history do not approach current rates. 26. 54. How much the world warms depends on human greenhouse gas emissions and on how sensitive the climate is to greenhouse gases. 27. The more carbon dioxide, CO2, is emitted in the 21st century, the hotter the world will be by 2100. For a doubling of greenhouse gas concentrations, the global mean temperature would rise by about 2.54 degrees Celsius (4.57.2 degrees Fahrenheit). 28. If emissions of CO2 stopped abruptly and there was no use of negative emission technologies, the Earth's climate would not start moving back to its pre-industrial state. Temperatures would stay at the same high level for several centuries. After about 1,000 years, 20% to 30% of human-emitted CO2 would remain in the atmosphere. The ocean and land would not have taken them. This would commit the climate to a warmer state long after emissions have stopped. 29. With current mitigation policies, the temperature will be about 2.7 degrees Celsius (2.0-3.6 degrees Celsius) above pre-industrial levels by 2100. It would rise by 2.4 degrees Celsius (4.3 degrees Fahrenheit) if governments achieved all their unconditional pledges and targets. If all the countries that have set or are considering net zero targets achieve them, the temperature will rise by around 1.8 degrees Celsius (3.2 degrees Fahrenheit). There is a big gap between national plans and commitments and the actions that governments have taken around the world. 30. Weather. Large increases in both the frequency and intensity of extreme weather events, for increasing degrees of global warming, are expected. 31.18. The lower and middle atmosphere, where nearly all weather occurs, are heating due to the greenhouse effect. 32. Evaporation and atmospheric moisture content increases, temperatures rise. 33. Water vapor is a greenhouse gas, so this process is a self-reinforcing feedback. 34. The excess water vapor also gets caught up in storms. This makes them more intense, larger, and potentially longer lasting. This in turn causes rain and snow events to become stronger and leads to increased risk of flooding. Extra drying worsens natural dry spells and droughts. This increases risk of heat waves and wildfires. 33. Scientists have identified human activities as the cause of recent climate trends. They are now able to estimate the impact of climate change on extreme weather events using a process called extreme event attribution. For instance, such research can look at historical data for a region and conclude that a specific heat wave was more intense due to climate change. 35. In addition, the time shifts of the season onsets, changes in the length of the season durations have been reported in many regions of the world. 36, 37, 38, 39, 40, as a result of changes in climatic patterns and rising global temperatures, extreme weather events like heat waves and heavy precipitation are occurring more frequently and with increasing severity. 41. Heat waves and temperature extremes. New high temperature records have outpaced new low temperature records on a growing portion of Earth's surface. 42. U.S. heat waves have increased in frequency, average duration, and intensity. 43. Also, heat wave seasons have grown in length. 43. Map of increasing heatwave trends, frequency and cumulative intensity, over the mid-latitudes in Europe, July-August 1979-2020, 44. Heatwaves over land have become more frequent and more intense in almost all world regions since the 1950s, due to climate change. Heatwaves are more likely to occur simultaneously with droughts. Marine heatwaves are twice as likely as they were in 1980. 45. Climate change will lead to more very hot days and fewer very cold days. 46. 7. There are fewer cold waves. 31. 8. Experts can often attribute the intensity of individual heat waves to global warming. Some extreme events would have been nearly impossible without human influence on the climate system. A heatwave that would occur once every 10 years before global warming started now occurs 2.8 times as often. Under further warming, heatwaves are set to become more frequent. An event that would occur every 10 years would occur every other year if global warming reaches 2 degrees Celsius, 3.6 degrees Fahrenheit. 47. Heat stress is related to temperature. 48. It also increases if humidity is higher. The wet bulb temperature measures both temperature and humidity. Humans cannot adapt to a wet bulb temperature above 35 degrees Celsius, 95 degrees Fahrenheit. This heat stress can kill people. If global warming is kept below 1.5 or 2 degrees Celsius, 2.7 or 3.6 degrees Fahrenheit, it will probably be possible to avoid this deadly heat and humidity in most of the tropics. But there may still be negative health impacts. 49. 50. There is some evidence climate change is leading to a weakening of the polar vortex. This would make the jet stream more wavy. 51. This would lead to outbursts of very cold winter weather across parts of Eurasia, 52, and North America and incursions of very warm air into the Arctic. 53, 54, 55. Rain. Warming increases global average precipitation. Precipitation is when water vapor condenses out of clouds, such as rain and snow. 56, 10, 57. Higher temperatures increase evaporation and surface drying. As the air warms, it can hold more water. For every degree Celsius, it can hold 7% more water vapor. 56, 10, 57. Scientists have observed changes in the amount, intensity, frequency, and type of precipitation. 57. Overall, climate change is causing longer hot dry spells, broken by more intense rainfall. 58, 151, 154. Climate change has increased contrasts in rainfall amounts between wet and dry seasons. Wet seasons are getting wetter and dry seasons are getting drier. In the northern high latitudes, warming has also caused an increase in the amount of snow and rain. 56, 10, 57. In the southern hemisphere, the rain associated with the storm tracks has shifted south. Changes in monsoons vary a lot. More monsoon systems are becoming wetter than drier. In Asia, summer monsoons are getting wetter. The West African monsoon is getting wetter over the central Sahel, and drier in the far western Sahel. 56, 10, 58. Extreme storms. New Orleans submerged after Hurricane Katrina, September 2005. Storms become wetter under climate change. These include tropical cyclones and extratropical cyclones. Both the maximum and mean rainfall rates increase. This more extreme rainfall is also true for thunderstorms in some regions. 59. Furthermore, tropical cyclones and storm tracks are moving towards the poles. This means some regions will see large changes in maximum wind speeds. 59. 60. Scientists expect there will be fewer tropical cyclones, but they expect their strength to increase. 60. There has probably been an increase in the number of tropical cyclones that intensify rapidly. 59. Meteorological and seismological data indicate a widespread increase in wind-driven global ocean wave energy in recent decades that has been attributed to an increase in storm intensity over the oceans due to climate change. 61, 62, 63. Atmospheric turbulence dangerous for aviation, hard to predict or that cannot be avoided by flying higher, probably increases due to climate change. 64. Land. The 6th IPCC assessment report projects changes in average soil moisture at 2.0 degrees Celsius of warming, as measured in standard deviations from the 1850 to 1900 baseline. Floods. Due to an increase in heavy rainfall events, floods are likely to become more severe when they do occur. 56, 11, 55. The interactions between rainfall and flooding are complex. There are some regions in which flooding is expected to become rarer. This depends on several factors. These include changes in rain and snowmelt, but also soil moisture. 56:11:56 Climate change leaves soils drier in some areas, so they may absorb rainfall more quickly. This leads to less flooding. Dry soils can also become harder. In this case, heavy rainfall runs off into rivers and lakes. This increases risks of flooding. 56:11:55 Droughts. A dry lake bed in California. In 2022, the state was experiencing its most serious drought in 1,200 years, worsened by climate change. 65. Climate change affects many factors associated with droughts. These include how much rain falls and how fast the rain evaporates again. Warming over land increases the severity and frequency of droughts around much of the world. 66:56:10:57 In some tropical and subtropical regions of the world, there will probably be less rain due to global warming. This will make them more prone to drought. Droughts are set to worsen in many regions of the world. These include Central America, the Amazon and southwestern South America. They also include West and Southern Africa. The Mediterranean and southwestern Australia are also some of these regions. 56:11:57 Higher temperatures increase evaporation. This dries the soil and increases plant stress. Agriculture suffers as a result. This means even regions where overall rainfall is expected to remain relatively stable will experience these impacts. 56:11:57 These regions include Central and Northern Europe. Without climate change mitigation, around one-third of land areas are likely to experience moderate or more severe drought by 2100. 56:11:57 Due to global warming, droughts are more frequent and intense than in the past. 67. Several impacts make their impacts worse. These are increased water demand, population growth and urban expansion in many areas. 68. Land restoration can help reduce the impact of droughts. One example of this is agroforestry. 69. Wildfires. Wildfire disasters, those claiming at least 10 lives or affecting over 100 people, have increased substantially in recent decades. 70. Climate change intensifies heatwaves and droughts that dry vegetation, which in turn fuels wildfires. 70. Climate change promotes the type of weather that makes wildfires more likely. In some areas, an increase of wildfires has been attributed directly to climate change. Evidence from Earth's past also shows more fire in warmer periods. 71. Climate change increases evapotranspiration. This can cause vegetation and soils to dry out. When a fire starts in an area with very dry vegetation, it can spread rapidly. Higher temperatures can also lengthen the fire season. This is the time of year in which severe wildfires are most likely, particularly in regions where snow is disappearing. 72. Weather conditions are raising the risks of wildfires. But the total area burnt by wildfires has decreased. This is mostly because savanna has been converted to cropland, so there are fewer trees to burn. Prescribed burning is an indigenous practice in the US and Australia. Prescribed burning is an indigenous practice in the US and Australia. It can reduce wildfire burning. 72. The carbon released from wildfires adds to carbon dioxide in Earth's atmosphere and therefore contributes to the greenhouse effect. Climate models do not yet fully reflect this climate change feedback. 31.20. Oceans. Oceans have taken up almost 90% of the excess heat accumulated on Earth due to global warming. 73. Climate change causes a drop in the ocean's pH value, called ocean acidification, times series of atmospheric CO2 at Mauna Loa, in parts per million volume, ppmv, red, surface ocean PCO2, mu ATM, blue, and surface ocean pH green, at Ocean Station Aloha in the subtropical North Pacific. Ocean. 74.75. There are many effects of climate change on oceans. One of the most important is an increase in ocean temperatures. More frequent marine heatwaves are linked to this. The rising temperature contributes to a rise in sea levels due to the expansion of water as it warms and the melting of ice sheets on land. Other effects on oceans include sea ice decline, reducing pH values and oxygen levels, as well as increased ocean stratification. All this can lead to changes of ocean currents, for example a weakening of the Atlantic Meridional Overturning Circulation (AMOC). 76. The main cause of these changes are the emissions of greenhouse gases from human activities, mainly burning of fossil fuels and deforestation. Carbon dioxide and methane are examples of greenhouse gases. The additional greenhouse effect leads to ocean warming because the ocean takes up most of the additional heat in the climate system. 77. The ocean also absorbs some of the extra carbon dioxide that is in the atmosphere. This causes the pH value of the seawater to drop. 78. Scientists estimate that the ocean absorbs about 25% of all human-caused CO2 emissions. 78. The various layers of the oceans have different temperatures. For example, the water is colder towards the bottom of the ocean. This temperature stratification will increase as the ocean surface warms due to rising air temperatures. 79. 471. Connected to this is a decline in mixing of the ocean layers, so that warm water stabilizes near the surface. A reduction of cold, deep water circulation follows. The reduced vertical mixing makes it harder for the ocean to absorb heat. So a larger share of future warming goes into the atmosphere and land. One result is an increase in the amount of energy available for tropical cyclones and other storms. Another result is a decrease in nutrients for fish in the upper ocean layers. These changes also reduce the ocean's capacity to store carbon. 80. At the same time, contrasts in salinity are increasing. Salty areas are becoming saltier and fresher areas less salty. 81. Warmer water cannot contain the same amount of oxygen as cold water. As a result, oxygen from the oceans moves to the atmosphere. Increased thermal stratification may reduce the supply of oxygen from surface waters to deeper waters. This lowers the water's oxygen content even more. 82. The ocean has already lost oxygen throughout its water column. Oxygen minimum zones are increasing in size worldwide. 79. 471. Sea level rise. The global average sea level has risen about 250 millimeters, 9.8 in, since 1880, 83, increasing the elevation on top of which other types of flooding, high tide flooding and storm surge, occur. Long-term sea level rise occurs in addition to intermittent tidal flooding. NOAA predicts different levels of sea level rise for coastlines within a single country. 84. Between 1901 and 2018, the average sea level rose by 15 to 25 cm, 6'10", and with an increase of 2.3 millimeters, 0.091 in, per year since the 1970s. 85, 12, 16. This was faster than the sea level had ever risen over at least the past 3,000 years. 85, 12, 16. The rate accelerated to 4.62 millimeters, 0.182 in, per year for the decade 2013-2022. 86. Climate change due to human activities is the main cause. 87, 5, 8. Between 1993 and 2018, melting ice sheets and glaciers accounted for 44% of sea level rise, with another 42% resulting from thermal expansion of water. 88, 15, 76. Sea level rise lags behind changes in the Earth's temperature by many decades, and sea level rise will therefore continue to accelerate between now and 2050 in response to warming that has already happened. 89. What happens after that depends on human greenhouse gas emissions. If there are very deep cuts in emissions, sea level rise would slow between 2050 and 2100. It could then reach by 2100 slightly over 30 centimeters, 1 foot from now, and approximately 60 centimeters, 2 feet from the 19th century. With high emissions it would instead accelerate further, and could rise by 1.0 meters, 31/3 of a foot, or even 1.6 meters, 51/3 of a foot by 2100. 87, 85, 1302. In the long run, sea level rise would amount to 2-3 meters, 7-10 feet over the next 2,000 years if warming stays to its current 1.5 degrees Celsius, 2.7 degrees Fahrenheit over the pre-industrial past. It would be 19 to 22 meters, 62-72 feet, if warming peaks at 5 degrees Celsius, 9.0 degrees Fahrenheit. 87, 21. Ice and snow. Earth lost 28 trillion tons of ice between 1994 and 2017, with melting grounded ice sheets and glaciers raising the global sea level by 34.6 plus or minus 3.1 millimeters. 90. The rate of ice loss has risen by 57% since the 1990s, minus from 0.8 to 1.2 trillion tons per year. 90. Melting of glacial mass is approximately linearly related to temperature rise. 91. The cryosphere, the area of the Earth covered by snow or ice, is extremely sensitive to changes in global climate. 92. There has been an extensive loss of snow on land since 1981. Some of the largest declines have been observed in the spring. 93. During the 21st century, snow cover is projected to continue its retreat in almost all regions. 94, 39 to 69. Glaciers decline. Since the beginning of the 20th century, there has been a widespread retreat of glaciers. 95, 12, 15. Those glaciers that are not associated with the polar ice sheets lost around 8% of their mass between 1971 and 2019. 95, 12, 75. In the Andes in South America and in the Himalayas in Asia, the retreat of glaciers could impact water supply. 96, 97. The melting of those glaciers could also cause landslides or glacial lake outburst floods. 98. Ice sheets decline. The melting of the Greenland and West Antarctic ice sheets will continue to contribute to sea level rise over long time scales. The Greenland ice sheet loss is mainly driven by melt from the top. Antarctic ice loss is driven by warm ocean water melting the outlet glaciers. 95, 12, 15. Future melt of the West Antarctic ice sheet is potentially abrupt under a high emission scenario, as a consequence of a partial collapse. 99, 595 to 596. Part of the ice sheet is grounded on bedrock below sea level. This makes it possibly vulnerable to the self-enhancing process of marine ice sheet instability. Marine ice cliff instability could also contribute to a partial collapse, but there is limited evidence for its importance. 95, 12, 69, 12, 70. A partial collapse of the ice sheet would lead to rapid sea level rise and a local decrease in ocean salinity. It would be irreversible for decades and possibly even millennia. 99, 595 to 596. The complete loss of the West Antarctic ice sheet would cause over 5 meters, 16 feet, of sea level rise. 100. In contrast to the West Antarctic ice sheet, melt of the Greenland ice sheet is projected to take place more gradually over millennia. 99, 595 to 596. Sustained warming between 1 degree Celsius, 1.8 degrees Fahrenheit, low confidence, and 4 degrees Celsius, 7.2 degrees Fahrenheit, medium confidence, would lead to a complete loss of the ice sheet. This would contribute 7 meters, 23 feet, to sea levels globally. 25, 363. The ice loss could become irreversible due to a further self-enhancing feedback. This is called the elevation surface mass balance feedback. When ice melts on top of the ice sheet, the elevation drops. Air temperature is higher at lower altitudes, so this promotes further melting. 25, 362. Sea ice decline. Reporting the reduction in Antarctic sea ice extent in mid-2023, researchers concluded that a regime shift may be taking place, in which previously important relationships no longer dominate sea ice variability. Ice sheet is projected to take place more gradually over millennia. 99, 595 to 596. Sustained warming between 1 degree Celsius, 1.8 degrees Fahrenheit, low confidence, and 4 degrees Celsius, 7.2 degrees Fahrenheit, medium confidence, would lead to a complete loss of the ice sheet. This would contribute 7 meters, 23 feet, to sea levels globally. 25, 363. The ice loss could become irreversible due to a further self-enhancing feedback. This is called the elevation surface mass balance feedback. When ice melts on top of the ice sheet, the elevation drops. Air temperature is higher at lower altitudes, so this promotes further melting. 25, 362. Sea ice decline. Reporting the reduction in Antarctic sea ice extent in mid-2023, researchers concluded that a regime shift may be taking place, in which previously important relationships no longer dominate sea ice variability. 101. Sea ice reflects 50% to 70% of the incoming solar radiation back into space. Only 6% of incoming solar energy is reflected by the ocean. 102. As the climate warms, the area covered by snow or sea ice decreases. After sea ice melts, more energy is absorbed by the ocean, so it warms up. This ice albedo feedback is a self-reinforcing feedback of climate change. 103. Large-scale measurements of sea ice have only been possible since satellites came into use. 104. Sea ice in the Arctic has declined in recent decades in area and volume due to climate change. It has been melting more in summer than it refreezes in winter. The decline of sea ice in the Arctic has been accelerating during the early 21st century. It has a rate of decline of 4.7% per decade. It has declined over 50% since the first satellite records. 105, 106, 107. Ice-free summers are expected to be rare at 1.5 degrees Celsius, 2.7 degrees Fahrenheit degrees of warming. They are set to occur at least once every decade with a warming level of 2 degrees Celsius, 3.6 degrees Fahrenheit. 108, 8. The Arctic will likely become ice-free at the end of some summers before 2050. 95, 9. Sea ice extent in Antarctica varies a lot year by year. This makes it difficult to determine a trend, and record highs and record lows have been observed between 2013 and 2023. The general trend since 1979, the start of the satellite measurements, has been roughly flat. Between 2015 and 2023, there has been a decline in sea ice, but due to the high variability, this does not correspond to a significant trend. 109. Permafrost thawing. Globally, permafrost warmed by about 0.3 degrees Celsius between 2007 and 2016. The extent of permafrost has been falling for decades. More decline is expected in the future. 95. 1280. Permafrost thaw makes the ground weaker and unstable. The thaw can seriously damage human infrastructure in permafrost areas such as railways, settlements and pipelines. 110. 236. Thawing soil can also release methane and CO2 from decomposing microbes. This can generate a strong feedback loop to global warming. 111. 112. Some scientists believe that carbon storage in permafrost globally is approximately 1600 gigatons. This is twice the atmospheric pool. 113. Wildlife and nature. Part of the Great Barrier Reef in Australia in 2016 after a coral bleaching event, partly caused by rising ocean temperatures and marine heatwaves. Recent warming has had a big effect on natural biological systems. 114. 81 species worldwide are moving poleward to colder areas. On land, species may move to higher elevations. Marine species find colder water at greater depths. 10. Climate change had the third biggest impact on nature out of various factors in the 5 decades up to 2020. Only change in land use and sea use and direct exploitation of organisms had a bigger impact. 115. The impacts of climate change on nature are likely to become bigger in the next few decades. 116. The stresses caused by climate change, combined with other stresses on ecological systems such as land conversion, land degradation, harvesting, and pollution. They threaten substantial damage to unique ecosystems. They can even result in their complete loss and the extinction of species. 117. 118. This can disrupt key interactions between species within ecosystems. This is because species from one location do not leave the warming habitat at the same rate. The result is rapid changes in the way the ecosystem functions. 10. Impacts include changes in regional rainfall patterns. Another is earlier leafing of trees and plants over many regions. Movements of species to higher latitudes and altitudes. 119. Changes in bird migrations, and shifting of the ocean's plankton and fish from cold to warm adapted communities or other impacts. 120. These changes of land and ocean ecosystems have direct effects on human well-being. 121, 122, 385. For instance, ocean ecosystems help with coastal protection and provide food. 122, 385. Freshwater and land ecosystems can provide water for human consumption. Furthermore, these ecosystems can store carbon. This helps to stabilize the climate system. 121. Ecosystems on land. Climate change is a major driver of biodiversity loss in different land types. These include cool conifer forests, savannas, Mediterranean climate systems, tropical forests, and the Arctic tundra. 123, 239. In other ecosystems, land use change may be a stronger driver of biodiversity loss, at least in the near term. 123, 239. Beyond 2050, climate change may be the major cause of biodiversity loss globally. 123, 239. Climate change interacts with other pressures. These include habitat modification, pollution and invasive species. Through this interaction, climate change increases the risk of extinction for many terrestrial and freshwater species. 124. At 1.2 degrees Celsius, 2.2 degrees Fahrenheit, of warming, around 2023, 125, some ecosystems are threatened by mass die-offs of trees and from heatwaves. 126. At 2 degrees Celsius, 3.6 degrees Fahrenheit, of warming, around 10% of species on land would become critically endangered. This differs by group. For instance, insects and salamanders are more vulnerable. 12. 259. The rate of global tree cover loss has approximately doubled since 2001, to an annual loss approaching an area the size of Italy. 127. Rainfall on the Amazon rainforest is recycled when it evaporates back into the atmosphere instead of running off away from the rainforest. This water is essential for sustaining the rainforest. Due to deforestation, the rainforest is losing this ability. This effect is even worse because climate change brings more frequent droughts to the area. The higher frequency of droughts in the first 2 decades of the 21st century and other data signal that a tipping point from rainforest to savanna might be close. A 2019 study concluded that this ecosystem could begin a 50-year-long collapse to a savanna around 2021. After that, it would become increasingly and disproportionately more difficult to prevent or reverse this shift. 128, 129, 130. Marine ecosystems. Climate change will affect coral reef ecosystems through sea level rise, changes to the frequency and intensity of tropical storms, and altered ocean circulation patterns. When combined, all of these impacts dramatically alter ecosystem function, as well as the goods and services coral reef ecosystems provide. 131. Marine heatwaves are happening more often. They have widespread impacts on life in the oceans. These include mass dying events and coral bleaching. 132. Harmful algae blooms have increased. This is in response to warming waters, loss of oxygen and eutrophication. 133. 451. Melting sea ice destroys habitat, including for algae that grows on its underside. 134. Ocean acidification can harm marine organisms in various ways. Shell-forming organisms like oysters are particularly vulnerable. Some phytoplankton and seagrass species may benefit. However, some of these are toxic to fish phytoplankton species. Their spread poses risks to fisheries and aquaculture. Fighting pollution can reduce the impact of acidification. 135. Warm water coral reefs are very sensitive to global warming and ocean acidification. Coral reefs provide a habitat for thousands of species. They provide ecosystem services such as coastal protection and food. But 70–90% of today's warm water coral reefs will disappear even if warming is kept to 1.5 degrees Celsius, 2.7 degrees Fahrenheit. 136. 179. Coral reefs are framework organisms. They build physical structures that form habitats for other sea creatures. Other framework organisms are also at risk from climate change. Mangroves and seagrass are considered to be at moderate risk from lower levels of global warming. 136. 225. Tipping points and irreversible impacts. There is a number of places around the globe which can pass a tipping point around a certain level of warming and eventually transition to a different state. 137. 138. The climate system exhibits threshold behavior, or tipping points when parts of the natural environment enter into a new state. Examples are the runaway loss of ice sheets or the dieback of forests. 139. 140. Tipping behavior is found in all parts of the climate system. These include ecosystems, ice sheets, and the circulation of the ocean and atmosphere. 141. Tipping points are studied using data from Earth's distant past and by physical modeling. 139. There is already moderate risk of global tipping points at 1 degree Celsius, 1.8 degrees Fahrenheit above pre-industrial temperatures. That becomes a high risk at 2.5 degrees Celsius, 4.5 degrees Fahrenheit. 136. 254. 258. It is possible that some tipping points are close or have already been crossed. Examples are the West Antarctic and Greenland ice sheets, the Amazon rainforest, and warm water coral reefs. 142. Tipping points are perhaps the most dangerous aspect of future climate change, potentially leading to irreversible impacts on society. 143. A collapse of the Atlantic meridional overturning circulation would likely have rainfall in India and lead to severe drops in temperature in northern Europe. 144. Many tipping points are interlinked such that triggering one may lead to a cascade of effects. 145. This remains a possibility even well below 2 degrees Celsius, 3.6 degrees Fahrenheit, of warming. 146. A 2018 study states that 45% of environmental problems, including those caused by climate change, are interconnected. This increases the risk of a domino effect. 147. 148. Further impacts may be irreversible, at least over the timescale of many human generations. 149. 785. This includes warming of the deep ocean and acidification. These are set to continue even when global temperatures stop rising. 150. In biological systems, the extinction of species would be an irreversible impact. 149. 785. In social systems, unique cultures may be lost. 149. 785. Climate change could make it more likely that endangered languages disappear. 151. Health, food security and water security. Humans have a climate niche. This is a certain range of temperatures in which they flourish. Outside that niche, conditions are less favorable. This leads to negative effects on health, food security and more. This niche is a mean annual temperature below 29 degrees Celsius. As of May 2023, 60 million people lived outside this niche. With every additional 0.1 degree of warming, 140 million people will be pushed out of it. 152. Health. The effects of climate change on human health are profound because they increase heat-related illnesses and deaths, respiratory diseases, and the spread of infectious diseases. There is widespread agreement among researchers, health professionals and organizations that climate change is the biggest global health threat of the 21st century. 153. 154. Rising temperatures and changes in weather patterns are increasing the severity of heat waves, extreme weather and other causes of illness, injury or death. Heat waves and extreme weather events have a big impact on health both directly and indirectly. When people are exposed to higher temperatures for longer time periods, they might experience heat illness and heat-related death. 155. In addition to direct impacts, climate change and extreme weather events cause changes in the biosphere. Climate change will impact where infectious diseases are able to spread in the future. Many infectious diseases will spread to new geographic areas where people have not previously been exposed to them. 156. 157. Certain diseases that are carried and spread by living hosts such as mosquitoes and ticks known as vectors may become more common in some regions. Affected diseases include dengue fever and malaria. 155. Contracting waterborne diseases such as diarrheal disease will also be more likely. 158. The effects of climate change on mental health and well-being are being documented as the consequences of climate change become more tangible and impactful. This is especially the case for vulnerable populations and those with pre-existing serious mental illness. 159. There are three broad pathways by which these effects can take place: directly, indirectly, or via awareness. 160. The direct pathway includes stress-related conditions caused by exposure to extreme weather events. These include post-traumatic stress disorder (PTSD). Scientific studies have linked mental health to several climate-related exposures. These include heat, humidity, rainfall, drought, wildfires, and floods. 161. The indirect pathway can be disruption to economic and social activities. An example is when an area of farmland is less able to produce food. 161. The third pathway can be of mere awareness of the climate change threat, even by individuals who are not otherwise affected by it. 160. This especially manifests in the form of anxiety over the quality of life for future generations. 162. An additional aspect to consider is the detrimental impact climate change can have on green or blue natural spaces, which have been proven to have beneficial impact on mental health. 163. 164. Impacts of anthropogenic climate change, such as freshwater pollution or deforestation, degrade these landscapes and reduce public access to them. 165. Even when the green and blue spaces are intact, their accessibility is not equal across society, which is an issue of environmental justice and economic inequality. 166. Food security. Projected changes in average food availability represented as calorie consumption per capita population at risk of hunger and disability-adjusted life years under two shared socioeconomic pathways, the baseline, SSP2, and 3 South Sudanese pounds, scenario of high global rivalry and conflict. The red and the orange lines show projections for SSP3 assuming high and low intensity of future emissions and the associated climate change. 167. Climate change will affect agriculture and food production around the world. The reasons include the effects of elevated CO2 in the atmosphere. Higher temperatures and altered precipitation and transpiration regimes are also factors. Increased frequency of extreme events and modified weed, pest, and pathogen pressure are other factors. 168. 282 droughts result in crop failures and the loss of pasture for livestock. 169. Loss and poor growth of livestock cause milk yield and meat production to decrease. 170. The rate of soil erosion is 10 to 20 times higher than the rate of soil accumulation in agricultural areas that use no-till farming. In areas with tilling it is 100 times higher. Climate change worsens this type of land degradation and desertification. 11.5. Climate change is projected to negatively affect all 4 pillars of food security. It will affect how much food is available. It will also affect how easy food is to access through prices, food quality, and how stable the food system is. 171. Climate change is already affecting the productivity of wheat and other staples. 172. 173. In many areas, fishery catches are already decreasing because of global warming and changes in biochemical cycles. In combination with overfishing, warming waters decrease the amount of fish in the ocean. 312 per degree of warming, ocean biomass is expected to decrease by about 5%. Tropical and subtropical oceans are most affected, while there may be more fish in polar waters. 174. Water security. Water resources can be affected by climate change in various ways. The total amount of fresh water available can change, for instance due to dry spells or droughts. Heavy rainfall and flooding can have an impact on water quality. They can transport pollutants into water bodies through increased surface runoff. In coastal regions, more salt may find its way into water resources due to higher sea levels and more intense storms. Higher temperatures also directly degrade water quality. This is because warm water contains less oxygen. 175. Changes in the water cycle threaten existing and future water infrastructure. It will be harder to plan investments for water infrastructure. This is because there are significant uncertainties about future variability of the water cycle. 176. Between 1.5 and 2.5 billion people live in areas with regular water security issues. If global warming reaches 4 degrees Celsius, 7.2 degrees Fahrenheit, water insecurity would affect about twice as many people. 175. Water resources are likely to decrease in most dry subtropical regions and mid-latitudes. But they will increase in high latitudes. However, variable streamflow means even regions with increased water resources can experience additional short-term shortages. 177. 251. In the arid regions of India, China, the US and Africa, dry spells and drought are already affecting water availability. 175. Human settlements. Climate change is particularly likely to affect the Arctic, Africa, small islands, Asian megadeltas and the Middle East regions. 178. 179. Low latitude, less developed regions are most at risk of experiencing negative climate change impacts. 149. 795 to 796. The 10 countries of the Association of Southeast Asian Nations, ASEAN, are among the most vulnerable in the world to the negative effects of climate change. ASEAN's climate mitigation efforts are not in proportion to the climate change threats the region faces. 180. Impacts from heat. Overlap between future population distribution and extreme heat in a high-emission scenario. 181. Regions inhabited by a third of the human population could become as hot as the hottest parts of the Sahara within 50 years. This would happen if greenhouse gas emissions continue to grow rapidly without a change in patterns of population growth and without migration. The projected average temperature of above 29 degrees Celsius, 84 degrees Fahrenheit, for these regions would be outside the human temperature niche. This is a range for climate that is biologically suitable for humans. It is based on historical data of mean annual temperatures. The most affected regions have little adaptive capacity. 182, 183. Increased extreme heat exposure from climate change and the urban heat island effect threatens urban settlements. 184. This is made worse by the loss of shade from urban trees that cannot withstand the heat stress. 185. In 2019, the Crowther Lab from Zurich paired the climatic conditions of 520 major cities worldwide with the predicted climatic conditions of cities in 2050. It found that 22% of the major cities would have climatic conditions that do not exist in any city today. For instance, 2050 London would have a climate similar to 2019 Melbourne in Australia. Athens and Madrid would be like Fez in Morocco. Nairobi in Kenya would be like Maputo in Mozambique. The Indian city Pune would be like Bamako in Mali and Bamako would be like Niamey in Niger. Brasilia would be like Goiânia, both in Brazil. 186, 187. Low-lying coastal regions. Low-lying cities and other settlements near the sea face multiple simultaneous risks from climate change. They face flooding risks from sea level rise. In addition, they may face impacts from more severe storms, ocean acidification, and salt intrusion into the groundwater. Changes like continued development in exposed areas increase the risks that these regions face. 188. Floodplains in low-lying coastal areas will flood more frequently due to climate change, like this area of Myanmar which was submerged by Cyclone Nargis. Population density on the coasts is high. Estimates of the number of people at risk of coastal flooding from climate-driven sea level rise vary. Estimates range from 190 million, 189 to 300 million. It could even be 640 million in a worst-case scenario related to the instability of the Antarctic ice sheet. 190, 191 people are most affected in the densely populated low-lying megadeltas of Asia and Africa. 192. Small island developing states are especially vulnerable. They are likely to experience more intense storm surges, saltwater intrusion and coastal destruction. 193 low-lying small islands in the Pacific, Indian, and Caribbean regions even risk permanent inundation. This would displace their population. 194, 195, 196 on the islands of Fiji, Tonga and Western Samoa, migrants from outer islands inhabit low and unsafe areas along the coasts. 196 the entire populations of small atoll nations such as Kiribati, Maldives, the Marshall Islands, and Tuvalu are at risk of being displaced. 197, 194 this could raise issues of statelessness. 198 several factors increase their vulnerability. These are small size, isolation from other land, low financial resources, and lack of protective infrastructure. 194. Impacts on societies. Climate change has many impacts on society. 199 it affects health, the availability of drinking water and food, inequality and economic growth. The effects of climate change are often interlinked. They can exacerbate each other as well as existing vulnerabilities. 200, 201, 202 some areas may become too hot for humans to live in. 203, 204 climate-related changes or disasters may lead people in some areas to move to other parts of the country or to other countries. Some scientists describe the effects of climate change, with continuing increases in greenhouse gas emissions, as a climate emergency or climate crisis. 205, 206 some researchers 207, 208, and activists 209 describe them as an existential threat to civilization. Some define these threats under climate security. The consequences of climate change, and the failure to address it, can distract people from tackling its root causes. This leads to what some researchers have termed a climate doom loop. 210. Displacement and migration. Displacement is when people move within a country. Migration is when they move to another country. Some people use the terms interchangeably. Climate change affects displacement in several ways. More frequent and severe weather-related disasters may increase involuntary displacement. These destroy homes and habitats. Climate impacts such as desertification and rising sea levels gradually erode livelihoods. They force communities to abandon traditional homelands. Other forms of migration are adaptive and voluntary. They are based on individual or household decisions. 211, 1079 on the other hand, some households may fall into poverty or get poorer due to climate change. This limits their ability to move to less affected areas. 212. Migration due to climate and weather is usually within countries. But it is long distance. Slow onset disasters such as droughts and heat are more likely to cause long-term migration than weather disasters like floods. 212 Migration due to desertification and reduced soil fertility is typically from rural areas in developing countries to towns and cities. 213, 109. According to the Internal Displacement Monitoring Center, extreme weather events displaced approximately 30 million people in 2020. Violence and wars displaced approximately 10 million in the same year. There may have been a contribution of climate change to these conflicts. 214, 215 in 2018, the World Bank estimated that climate change will cause internal migration of between 31 and 143 million people by 2050. This would be as they escape crop failures, water scarcity, and sea level rise. The study covered only sub-Saharan Africa, South Asia, and Latin America. 216, 217. Sea level rise at the Marshall Islands, reaching the edge of a village from the documentary One Word. Conflict. Overlap between state fragility, extreme heat, and nuclear and biological catastrophic hazards, 181. Climate change is unlikely to cause international wars in the foreseeable future. However, climate change can increase the risk for interstate conflicts, such as civil wars, communal violence, or protests. 218 The IPCC Sixth Assessment Report concludes, climate hazards have affected armed conflict within countries, medium confidence, but the influence of climate is small compared to socio-economic, political, and cultural factors, high confidence. 219. Climate change can increase conflict risks by causing tensions about scarce resources like food, water and land, by weakening state institutions, by reducing the opportunity costs for impoverished individuals to join armed groups, and by causing tensions related to climate-induced migration. 220-219 Efforts to mitigate or adapt to climate change can also cause conflicts, for instance due to higher food and energy prices or when people are forcibly relocated from vulnerable areas. 221-222 Research has shown that climate change is not the most important conflict driver, and that it can only affect conflict risks under certain circumstances. 218 Relevant context factors include agricultural dependence, a history of political instability, poverty, and the political exclusion of ethnic groups. 223, 224, 225 Climate change has thus been described as a threat multiplier. 226 Yet, an impact of climate change on specific conflicts like the Syrian civil war, 227, 228, or the armed conflict in Darfur, 229, 230 remains hard to prove. Social impacts on vulnerable groups. Climate change does not affect people within communities in the same way. It can have a bigger impact on vulnerable groups such as women, the elderly, religious minorities and refugees than on others. 231. People living with disability. Climate impacts on disabled people have been identified by activists and advocacy groups as well as through the UNHCR adopting a resolution on climate change and the rights of people with disabilities. 1. People living in poverty. Climate change disproportionately affects poor people in low-income communities in developing countries around the world. 1. Those in poverty have a higher chance of experiencing the ill effects of climate change, due to their increased exposure and vulnerability. 232 A 2020 World Bank paper estimated that between 32 million to 132 million additional people will be pushed into extreme poverty by 2030 due to climate change. 233 Women. Climate change increases gender inequality. 234 It reduces women's ability to be financially independent. 235 And has an overall negative impact on the social and political rights of women. This is especially the case in economies that are heavily based on agriculture. 234 1. Indigenous peoples. Indigenous communities tend to rely more on the environment for food and other necessities. This makes them more vulnerable to disturbances in ecosystems. 236 Indigenous communities across the globe generally have bigger economic disadvantages than non-indigenous communities. This is due to the oppression they have experienced. These disadvantages include less access to education and jobs and higher rates of poverty. All this makes them more vulnerable to climate change. 237 Children. The Lancet Review on Health and Climate Change lists children among the worst affected by global warming. 238 Children are 14 to 44% more likely to die from environmental factors. 239 Possibility of societal collapse. Climate change has long been described as a severe risk to humans. Climate change as an existential threat has emerged as a key theme in the climate movement. People from small island nations also use this theme. There has not been extensive research in this topic. Existential risks are threats that could cause the extinction of humanity or destroy the potential of intelligent life on Earth. 240 Key risks of climate change do not fit that definition. However, some key climate risks do have an impact people's ability to survive. For instance, areas may become too hot to survive, or sea level rise may make it impossible to live at a specific location. 241, 242, 240. As of October 2024, the possibility of societal collapse became more probable. The number of articles speaking about climate change and societal collapse increased sharply. Leading climate scientists emphasize that climate change is a glaring symptom of a deeper systemic issue, ecological overshoot, which is an inherently unstable state that cannot persist indefinitely. To prevent it, they propose phase down fossil fuels, reduce methane emissions, overconsumption, and birth rate, switch to plant-based food, protect and restore ecosystems and adopt an ecological, post-growth economics which includes social justice. Climate change education should be integrated into core curriculums worldwide. 243, 244. Economic impacts. Regional median economic impacts predicted due to global warming by 2050 compared to present. 245. Economic forecasts of the impact of global warming vary considerably. The impacts are worse if there is insufficient adaptation. 246 Economic modeling may underrate the impact of catastrophic climatic changes. When estimating losses, economists choose a discount rate. This determines how much one prefers to have goods or cash now compared to at a future date. Using a high discount rate may understate economic losses. This is because losses for future generations weigh less heavily. 247. Economic impacts are bigger the more the temperature rises. 248 Scientists have compared impacts with warming of 1.5 degrees Celsius, 2.7 degrees Fahrenheit, and a level of 3.66 degrees Celsius, 6.59 degrees Fahrenheit. They use this higher figure to represent no efforts to stop emissions. They found that total damages at 1.5 degrees Celsius were 90% less than at 3.66 degrees Celsius. 136-256 One study found that global GDP at the end of the century would be 3.5% less if warming is limited to 3 degrees Celsius, 5.4 degrees Fahrenheit. This study excludes the potential effect of tipping points. Another study found that excluding tipping points underestimates the global economic impact by a factor of 2 to 8. 136-256 Another study found that a temperature rise of 2 degrees Celsius, 3.6 degrees Fahrenheit, by 2050 would reduce global GDP by 2.5% minus 7.5%. By 2100 in this scenario the temperature would rise by 4 degrees Celsius, 7.2 degrees Fahrenheit. This could reduce global GDP by 30% in the worst case. 249. A 2024 study, which checked the data from the last 120 years, found that climate change has already reduced welfare by 29% and further temperature rise will raise the number to 47%. The temperature rise during the years 1960-2019 alone has cut current GDP per capita by 18%. A 1-degree warming reduces global GDP by 12%. An increase of 3 degrees by 2100 will reduce capital by 50%. The effects are similar to experiencing the 1929 Great Depression permanently. The correct social cost of carbon according to the study is $1065 per ton of CO2. 251. Global losses reveal rapidly rising costs due to extreme weather events since the 1970s. 110 socioeconomic factors have contributed to the observed trend of global losses. These factors include population growth and increased wealth. 252. Regional climatic factors also play a role. These include changes in precipitation and flooding events. It is difficult to quantify the relative impact of socioeconomic factors and climate change on the observed trend. 253. The trend suggests social systems are increasing vulnerable to climate change. 253. Economic inequality. Rich nations have done the most to fuel climate change. 254. Climate change has contributed to global economic inequality. Wealthy countries in colder regions have felt little overall economic impact from climate change or may have benefited. Poor hotter countries probably grew less than if there had been no global warming. 255. 256. Highly affected sectors. Climate change has a bigger impact on economic sectors directly affected by weather than on other sectors. 257. It heavily affects agriculture, fisheries and forestry. 258. It also affects the tourism and energy sectors. 257. Agriculture and forestry have suffered economic losses due to droughts and Climate Change Portal. Ecology Portal. Environment Portal. World Portal. Extreme Heat. 259. If global warming goes over 1.5 degrees Celsius, there may be limits to how much tourism and outdoor work can adapt. 260. In the energy sector, thermal power plants depend on water to cool them. Climate change can increase the likelihood of drought and fresh water shortages. Higher operating temperatures make them less efficient. This reduces their output. 261. Hydropower is affected by changes in the water cycle such as river flows. Diminished river flows can cause power shortages in areas that depend on hydroelectric power. Brazil relies on hydroelectricity, so it is particularly vulnerable. Rising temperatures, lower water flow, and changes in rainfall could reduce total energy production by 7% annually by the end of the century. 261. Climate change affects oil and natural gas infrastructure. This is also vulnerable to the increased risk of disasters such as storms, cyclones, flooding and rising sea levels. 262. Global warming affects the insurance and financial services sectors. 136. 212 to 213. 228. 252. Insurance is an important tool to manage risks. But it is often unavailable to poorer households. Due to climate change, premiums are going up for certain types of insurance, such as flood insurance. Poor adaptation to climate change further widens the gap between what people can afford and the costs of insurance, as risks increase. 263. In 2019, Munich Re said climate change could make home insurance unaffordable for households that are below average incomes. 264. It is possible that climate change has already begun to affect the shipping sector by impacting the Panama Canal. Lack of rainfall possibly linked to climate change reduced the number of ships passing through the canal per day, from 36 to 22 and by February 2024, it is expected to be 18. 265. Anthropocene. Climate change mitigation. Climate change mitigation, or decarbonization, is action to limit the greenhouse gases in the atmosphere that cause climate change. Climate change mitigation actions include conserving energy and replacing fossil fuels with clean energy sources. Secondary mitigation strategies include changes to land use and removing carbon dioxide, CO2, from the atmosphere. 1. 2. Current climate change mitigation policies are insufficient as they would still result in global warming of about 2.7 degrees Celsius by 2100. 3. Significantly above the 2015 Paris Agreement's 4. Goal of limiting global warming to below 2 degrees Celsius. 5. 6. Various aspects of climate change mitigation. Renewable energy, solar and wind power, in England, electrified public transport in France, a reforestation project in Haiti to remove carbon dioxide from the atmosphere, and an example of a plant-based meal. Solar energy and wind power can replace fossil fuels at the lowest cost compared to other renewable energy options. 7. The availability of sunshine and wind is variable and can require electrical grid upgrades, such as using long-distance electricity transmission to group a range of power sources. 8. Energy storage can also be used to even out power output, and demand management can limit power use when power generation is low. Cleanly generated electricity can usually replace fossil fuels for powering transportation, heating buildings, and running industrial processes. Certain processes are more difficult to decarbonize, such as air travel and cement production. Carbon capture and storage (CCS) can be an option to reduce net emissions in these circumstances, although fossil fuel power plants with CCS technology is currently a high-cost climate change mitigation strategy. 9. Human land use changes such as agriculture and deforestation cause about 1/4 of climate change. These changes impact how much CO2 is absorbed by plant matter and how much organic matter decays or burns to release CO2. These changes are part of the fast carbon cycle, whereas fossil fuels release CO2 that was buried underground as part of the slow carbon cycle. Methane is a short-lived greenhouse gas that is produced by decaying organic matter and livestock, as well as fossil fuel extraction. Land use changes can also impact precipitation patterns and the reflectivity of the surface of the Earth. It is possible to cut emissions from agriculture by reducing food waste, switching to a more plant-based diet, also referred to as low-carbon diet, and by improving farming processes. 10. Various policies can encourage climate change mitigation. Carbon pricing systems have been set up that either tax CO2 emissions or cap total emissions and trade emission credits. Fossil fuel subsidies can be eliminated in favor of clean energy subsidies, and incentives offered for installing energy efficiency measures or switching to electric power sources. 11. Another issue is overcoming environmental objections when constructing new clean energy sources and making grid modifications. Climate change mitigation aims to sustain ecosystems to maintain human civilization. This requires drastic cuts in greenhouse gas emissions. 12. 1-64 The Intergovernmental Panel on Climate Change IPCC defines mitigation of climate change as a human intervention to reduce emissions or enhance the sinks of greenhouse gases. 13. 2239. It is possible to approach various mitigation measures in parallel. This is because there is no single pathway to limit global warming to 1.5 or 2 degrees Celsius. 14. 109 There are 4 types of measures. 1. Sustainable energy and sustainable transport. 2. Energy conservation, including efficient energy use. 3. Sustainable agriculture and green industrial policy. 4. Enhancing carbon sinks and carbon dioxide removal (CDR), including carbon sequestration. The IPCC defined carbon dioxide removal as anthropogenic activities removing carbon dioxide (CO2) from the atmosphere and durably storing it in geological, terrestrial, or ocean reservoirs or in products. It includes existing and potential anthropogenic enhancement of biological or geochemical CO2 sinks and direct air carbon dioxide capture and storage (DACCS), but excludes natural CO2 uptake not directly caused by human activities. 13. Definitions and scope. Emission trends and pledges. GHG emissions 2020 by gas type. Without land use change using 100-year GWP total, 49.8 GTCO2e 15.5. CO2 mostly by fossil fuel, 72%, CH4 methane, 19%. N2O nitrous oxide, 6%, fluorinated gases, 3%. CO2 emissions by fuel type, 16. Coal, 39%, oil, 34%, gas, 21%, cement, 4%, others, 1.5%. Greenhouse gas emissions from human activities strengthen the greenhouse effect. This contributes to climate change. Most is carbon dioxide from burning fossil fuels, coal, oil, and natural gas. Human-caused emissions have increased atmospheric carbon dioxide by about 50% over Human-caused emissions have increased atmospheric carbon dioxide by about 50% over pre-industrial levels. Emissions in the 2010s averaged a record 56 billion tons (GT) a year. 17. In 2016, energy for electricity, heat and transport was responsible for 17. In 2016, energy for electricity, heat and transport was responsible for 73.2% of GHG emissions. Direct industrial processes accounted for 5.2%, waste for 3.2% and agriculture, forestry and land use for 18.4%. 18. Electricity generation and transport are major emitters. The largest single source is coal-fired power stations with 20% of greenhouse gas emissions. 19. Deforestation and other changes in land use also emit carbon dioxide and methane. The largest sources of anthropogenic methane emissions are agriculture, and gas venting and fugitive emissions from the fossil fuel industry. The largest agricultural methane source is livestock. Agricultural soils emit nitrous oxide, partly due to fertilizers. 20. There is now a political solution to the problem of fluorinated gases from refrigerants. This is because many countries have ratified the Kigali Amendment. 21. Carbon dioxide, CO2, is the dominant emitted greenhouse gas. Methane, CH4, emissions almost have the same short-term impact. 22. Nitrous oxide, N2O, and fluorinated gases, F gases, play a minor role. Livestock and manure produce 5.8% of all greenhouse gas emissions. 18. But this depends on the time frame used to calculate the global warming potential of the respective gas. 23. 24. Greenhouse gas, GHG, emissions are measured in CO2 equivalents. Scientists determine their CO2 equivalents from their global warming potential, GWP. This depends on their lifetime in the atmosphere. There are widely used greenhouse gas accounting methods that convert volumes of methane, nitrous oxide and other greenhouse gases to carbon dioxide equivalents. Estimates largely depend on the ability of oceans and land sinks to absorb these gases. Short-lived climate pollutants, SLCPs, persist in the atmosphere for a period ranging from days to 15 years. Carbon dioxide can remain in the atmosphere for millennia. 25. Short-lived climate pollutants include methane, hydrofluorocarbons, HFCs, tropospheric ozone and black carbon. Scientists increasingly use satellites to locate and measure greenhouse gas emissions and deforestation. Earlier, scientists largely relied on or calculated estimates of greenhouse gas emissions and governments' self-reported data. 26-27. Needed emissions cuts. Global greenhouse gas emission scenarios, based on policies and pledges as of 11/21. The annual Emissions Gap Report by UNEP stated in 2022 that it was necessary to almost halve emissions. To get on track for limiting global warming to 1.5 degrees Celsius, global annual GHG emissions must be reduced by 45% compared with emissions projections under policies currently in place in just 8 years, and they must continue to decline rapidly after 2030, to avoid exhausting the limited remaining atmospheric carbon budget. 10. XVI The report commented that the world should focus on broad-based economy-wide transformations and not incremental change. 10. XVI In 2022, the Intergovernmental Panel on Climate Change (IPCC) released its sixth assessment report on climate change. It warned that greenhouse gas emissions must peak before 2025 at the latest and decline 43% by 2030 to have a good chance of limiting global warming to 1.5 degrees Celsius (2.7 degrees Fahrenheit). 28-29, or in the words of Secretary General of the United Nations Antonio Guterres, main emitters must drastically cut emissions starting this year. 30. Pledges. Climate Action Tracker described the situation on the 9th of November 2021 as follows. The global temperature will rise by 2.7 degrees Celsius by the end of the century with current policies and by 2.9 degrees Celsius with nationally adopted policies. The temperature will rise by 2.4 degrees Celsius if countries only implement the pledges for 2030. The rise would be 2.1 degrees Celsius with the achievement of the long-term targets too. Full achievement of all announced targets would mean the rise in global temperature will peak at 1.9 degrees Celsius and go down to 1.8 degrees Celsius by the year 2100. 31. Experts gather information about climate pledges in the Global Climate Action Portal (NASCA). The scientific community is checking their fulfillment. 32. There has not been a definitive or detailed evaluation of most goals set for 2020. But it appears the world failed to meet most or all international goals set for that year. 33. 34. One update came during the 2021 United Nations Climate Change Conference in Glasgow. The group of researchers running the Climate Action Tracker looked at countries responsible for 85% of greenhouse gas emissions. It found that only 4 countries or political entities, the EU, UK, Chile and Costa Rica, have published a detailed official policy plan that describes the steps to realize 2030 mitigation targets. These 4 polities are responsible for 6% of global greenhouse gas emissions. 35. In 2021 the US and EU launched the Global Methane Pledge to cut methane emissions by 30% by 2030. The UK, Argentina, Indonesia, Italy and Mexico joined the initiative. Ghana and Iraq signaled interest in joining. A White House summary of the meeting noted those countries represent 6 of the top 15 methane emitters globally. 36. Israel also joined the initiative. 37. Low-carbon energy. Coal, oil, and natural gas remain the primary global energy sources even as renewables have begun rapidly increasing. 38. The energy system includes the delivery and use of energy. It is the main emitter of carbon dioxide, CO2. 39. 6 to 6 rapid and deep reductions in the carbon dioxide and other greenhouse gas emissions from the energy sector are necessary to limit global warming to well below 2 degrees Celsius. 39. 6 to 3 IPCC recommendations include reducing fossil fuel consumption, increasing production from low and zero carbon energy sources, and increasing use of electricity and alternative energy carriers. 39. 6 to 3. Nearly all scenarios and strategies involve a major increase in the use of renewable energy in combination with increased energy efficiency measures. 40. XXIII It will be necessary to accelerate the deployment of renewable energy sixfold from 0.25% annual growth in 2015 to 1.5% to keep global warming under 2 degrees Celsius. 41. Renewable energy sources, especially solar photovoltaic and wind power, are providing an increasing share of power capacity. 42. The competitiveness of renewable energy is a key to a rapid deployment. In 2020, onshore wind and solar photovoltaics were the cheapest source for new bulk electricity generation in many regions. 43. Renewables may have higher storage costs but non-renewables may have higher cleanup costs. 44. A carbon price can increase the competitiveness of renewable energy. 45. Solar and wind energy. The 150 MW Andasol Solar Power Station is a commercial parabolic trough solar thermal power plant, located in Spain. The Andasol plant uses tanks of molten salt to store solar energy so that it can continue generating electricity for 7.5 hours after the sun has stopped shining. 46. Wind and sun can provide large amounts of low-carbon energy at competitive production costs. 47. The IPCC estimates that these 2 mitigation options have the largest potential to reduce emissions before 2030 at low cost. 743. Solar photovoltaics (PV) has become the cheapest way to generate electricity in many regions of the world. 48. The growth of photovoltaics has been close to exponential. It has about doubled every 3 years since the 1990s. 49. 50. A different technology is concentrated solar power (CSP). This uses mirrors or lenses to concentrate a large area of sunlight onto a receiver. With CSP, the energy can be stored for a few hours. This provides supply in the evening. Solar water heating doubled between 2010 and 2019. 51. The Shepherd's Flat Wind Farm is an 845 MW MW nameplate capacity wind farm in the U.S. state of Oregon. Each turbine is a nameplate 2 or 2.5 MW electricity generator. Regions in the higher northern and southern latitudes have the greatest potential for wind power. 52. Offshore wind farms are more expensive, but offshore units deliver more energy per installed capacity with less fluctuations. 53. In most regions, wind power generation is higher in the winter when PV output is low. For this reason, combinations of wind and solar power lead to better balanced systems. 54. Other renewables. The 22,500 MW nameplate capacity Three Gorges Dam in the People's Republic of China, the largest hydroelectric power station in the world. Other well-established renewable energy forms include hydropower, bioenergy and geothermal energy. Hydroelectricity is electricity generated by hydropower and plays a leading role in countries like Brazil, Norway and China. 55. But there are geographical limits and environmental issues. 56. Tidal power can be used in coastal regions. Bioenergy can provide energy for electricity, heat and transport. Bioenergy, in particular biogas, can provide dispatchable electricity generation. 57. While burning plant-derived biomass releases CO2, the plants withdraw CO2 from the atmosphere while they grow. The technologies for producing, transporting and processing a fuel have a significant impact on the life cycle emissions of the fuel. 58. For example, aviation is starting to use renewable biofuels. 59. Geothermal power is electrical power generated from geothermal energy. Geothermal electricity generation is currently used in 26 countries. 6.